Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are still going through the grade 12 mathematics June 2022 paper 1 that was written by the Gauteng province learners. We are using this paper to basically revise all the topics and all the concepts that we have learned, right, throughout grade 10, 11, and 12, right? In this video tutorial, guys, we are going to be going through question 7, and question 7 basically deals with calculus. In question 7.1, guys, we are going to be using first principles to help us find the derivative of f of x. In question 7.2, we are going to be using the rules of differentiation to help us differentiate these two equations. So if you know that you struggle in applying the first principles formula, right, to basically find the derivative of f of x, right, please make sure that you watch this whole video tutorial. And if you also just struggle in where you're supposed to start in terms of applying the rules of differentiation to basically find the or to basically differentiate a given function, please make sure that you watch this entire video tutorial. Before we get started with the video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a new video tutorial, guys. And also, please make sure to share this video tutorial with your friends. Also, don't forget to give this video tutorial a huge thumbs up because that really helps the channel grow and it helps the channel reach more learners that want to better their mathematics marks, right? So without any further ado, guys, let's get started with today's video tutorial. Right, guys, so in question 7.1, we are told that we need to determine f prime of x, right? F prime of x, or find the derivative of f of x from first principles if f of x is given as negative 2x squared plus x, right? Okay, so if you have a look at your formula sheet, we are given this formula for finding the derivative of f of x using first principles, and that formula is given as f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, right? So that is basically the formula that we have to use to help us basically find the derivative of our f of x, right? So what is f of x plus h, right? So here, where we basically see an x, we need to substitute that with x plus h. Where we see an x, we need to substitute that with x plus h. Where we see an x, we need to substitute that with x plus h, right? So that is basically what this is telling us. All right, so we're going to do that. Okay, so f of x plus h is equal to, right, in our f of x formula, where we see an x, we're going to substitute it with x plus h. So it's minus 2x. We're going to say x plus h all squared plus, what is our x? X plus h, right? We're going to simplify this further. It's going to be minus 2. Okay, I'm going to show you a quick way in which we can basically expand that bracket. It's going to be square the first term, right? The first term is x. So x squared is x squared, right? Okay, and then you're going to multiply these two terms together. So x multiplied by h, right, is xh, and then you're going to double that, right? So it's going to be plus 2xh, and then you're going to basically square the last term, and the last term is positive positive h, right? And positive h squared is still positive h squared, right, plus x plus h. Okay, I'm going to show you how we can do this. If you don't basically get that method, you can also just use this. Okay, so I'm basically using the red parts to basically explain how I got that. But if you got it, you can just fast forward to the next step, right? So let's basically explain that there. So minus 2x plus h all squared plus x plus h, right? So here what we basically did, guys, we are basically expanding this bracket. There's a square there, right? So that means that we're going to write our bracket out, right? Twice, okay, plus x plus h, okay? And then how do you simplify that? It's going to be minus 2. X multiplied by x is going to be x squared. X multiplied by h is going to be plus xh. H multiplied by x is going to be plus xh. And h multiplied by h is going to be plus h squared plus x plus h, okay? Then if you simplify that further, it's going to be minus 2, right? It's going to be x squared, going to add all your like terms, plus xh plus xh is going to be plus 2xh, okay, plus h squared, okay, and then plus x plus h, okay? So that basically takes us to what we got there. Right? In case you don't get the whole, square the first term, multiply the first two terms together, double it, and square the last term. Okay, so that was just basically an additional explanation for learners that basically got confused there. Right? So let's basically continue. From here, we can basically now multiply this minus 2 in, right? So it's minus 2 multiplied by x squared. It's going to be minus 2x squared minus 2 multiplied by positive 2xh is going to be minus 4xh, and then minus 2 multiplied by positive h squared is going to be minus 2h squared, right? Plus, you're going to multiply this positive inside, so it's just going to be plus x and plus h, okay? And then here we're basically going to add any like terms that we have, and we can see here that we do not have any like terms. Therefore, our f of x plus h is equal to negative 2x squared minus 4xh minus 2h squared plus x plus h. Okay, so now what do we do with this information? We know that our f of x plus h is equal to minus 2x minus 2x squared minus 4xh minus 2h squared plus x plus h. And we already know that our f of x, right, was given as minus 2x squared plus x, right? Then now what do? We're going to substitute the value of f of x plus h into this formula, and we're going to substitute our f of x into this formula, and then we're going to simplify it further. Okay, so let us do that. So f prime of x, right, is equal to the limit as h approaches 0. Okay, so like I said, we're going to substitute the value for f of x plus h, and we found that f of x plus h is equal to, right, that value there. So it's minus 2x squared minus 4xh minus 2h squared plus x plus h, right? Okay, minus, okay, remember we've got a minus there, right? F of x, right? So what is our f of x value? Please make sure that you put a bracket there, because if you don't put that bracket there, you are going to basically forget that you're supposed to multiply that negative in, right? So what is our f of x, guys? We know that our f of x is negative 2x squared plus x, okay, all over our h. Cool stuff. Okay, we're going to simplify that further. Limit as h approaches 0, right? Okay, it's going to be negative 2x squared minus 4xh minus 2h squared plus x plus h. Then, you see here, this negative, we need to multiply it in. You see, you need to multiply it in. So if you didn't put that bracket there, you're going to make a silly mistake there. You're going to lose marks. Yeah. Right. So that negative multiplied by negative 2 x squared is going to be positive 2x squared. That negative multiplied by positive x is negative x all over h. Happiness. All right. Okay. And then yeah, guys, we're basically going to solve or add all our like terms. So we're going to look for all our like terms. We see that, okay, we've got minus 2x squared, positive 2x squared. So that is 0. Okay. Then you've got minus 4xh, right? Is there another xh somewhere there? There isn't. So it's just going to be the limit as h approaches 0 of minus 4xh. Continue. Right, so we've basically sorted that out. Then you've got minus 2h squared. Do we have another h squared somewhere there? We do not. So it's going to be minus 2h squared. Sorted that out, right? Then you've got positive x and you've got a negative x, right? So those two gives us a 0 plus that h there. Okay, so we've basically added all our like terms, and that is basically the final value that we have, right? So it's minus 4xh minus 2 h squared plus h over h, right? And then yeah, what do we need to do? We see that we've got a common factor of h. So it's going to be the limit as h approaches 0, right? We're going to take out an h. If you take out an h, what are you left with? Minus 4x minus 2h. Okay? Because when you multiply that h with that, you still need to get back to the negative 2h squared plus 1, right? Because if you multiply that h with that 1, you still need to get your positive h, right? All over h. Okay, and then what do we see happens here? The h and the h cancel, right? And we are basically going to be left with the limit as h approaches 0 of negative 4x minus 2h plus 1, right? And then here, what do we need to do, right? We need to substitute 0 where we see an h. So we basically have, okay, f prime of x is equal to the limit as h approaches 0 of negative 4x minus 2h plus 1. And like I said, where you see an h, we are going to substitute 0, right? Therefore, what is our final answer? It's going to be negative 4x, right? I'm just going to do a side note here so you see what's going on. Negative 4x. We said where you see an h, you need to substitute it 0 plus 1, right? So therefore, if you do that, what is your answer, right? It's going to be negative 4x minus 2 multiplied by 0 is 0 plus 1, right? Therefore, f prime of x is equal to negative 4x plus 1. So f prime of x is equal to negative 4x plus 1. Right. So let us go on to the next question. Question 7.2 asks us to basically determine. Okay, so 7.2.1 asks us to find d of x if you're given negative 5x over the square root of x minus x squared over 5, right? Guys, the first thing you need to do here is you basically need to simplify the expression. First thing, simplify. See if you can't simplify this expression, okay? So now let's have a look at that, okay? So given this expression, can we actually simplify it, right? I'm going to write the first step here. We need to simplify. Check to see if you can't simplify the expression, okay? Once you've basically simplified the expression, then you can basically go on to basically find the derivative using your rules of differentiation. Okay, so the first step, let's try and see if we can simplify this expression, right? So d of x is equal to, okay, let's simplify that. We see that we've got a third there, okay? So square root of x, guys, we know that the square root of x is the same as saying x to the power of 1 over 2. Do we all agree? Okay. If we don't agree, please make sure that you watch this video tutorial where I'll go through basically the laws of exponents and where I also explain what you need to do if you're given a third and you have to turn that third into an exponent. Okay. Or an exponential expression, right? Okay, so here we've got now negative 5 over x, negative 5x all over that square root of x, right? Okay, can be written as x to the power of 1 over 2, okay, minus, we actually write that nicely so that someone doesn't get confused. Okay, x to the exponent of 1 over 2 minus x to the power of 2, or x to the exponent of 2 over 5. Okay, can we simplify this further? Yes, we can. So it's going to be d of x, right? Okay, so this x to the exponent 1 over 5 can go up to the numerator. Do we all agree? Right? It can go up to the numerator. So it's going to be negative 5x multiplied by x to the power of, if it goes up, what happens to the exponent? It becomes a negative 1 over 2. Okay? So it's going to be negative 1 over 2, right? Okay? So if the exponent, if you move a variable up, right, the exponent basically changes its sign. Okay, right? So minus 1 over 5, I'm going to write it as 1 over 5 times it by x to the power of 2. Okay, can we simplify this any further, guys? We cannot. Okay, actually we can. Yes, we can, right? We can simplify that further. Okay, so we had d of x, okay, and then we had negative 5 to the power of x times it by x to the power of negative 1 over 2 minus, I said 1 over 5 times it by x to the power of 2. Yes, right? And I'm saying that we can actually simplify that further, right? Here, we can simplify that further. Negative 5x multiplied by x to the power of negative 1 over 2. What do we see here? Exponential laws. Ne? So we see now everything that we learned from grade 9, grade 10, it's coming together. Yeah. So if something is not hlanganing, we're going to have a problem. If you don't know how to basically apply exponential laws, you get stuck here. Yeah, right? You get stuck here, right? So please make sure that you also watch this video tutorial to just brush up on your exponential laws. Okay, so let's continue. Okay, so dx, what does the exponential law say? Okay, so with the exponential law, especially the product rule, it says that if you've got the same basis, right, you need to add your exponents, right? So here we can see that we've got the same base because it's negative 5x, right? And you've got the x to the power of negative 1 over 2, right? So we need to apply that product rule when it comes to these bases, and it says that we need to basically add your exponents, right? So it's going to be negative 5x to the power of 1, because there's 1 there, there's a 1 there, minus 1 over 2, okay? Or in case, just to make sure that no one gets confused and thinks that we're supposed to subtract, okay? So it's 1 plus that negative 1 over 2, right? Okay, minus 1 over 5 x to the power of 2, okay? If you simplify that further, your d of x is negative 5x, okay? 1 minus, because positive multiplied by negative is still a negative. So it's going to be 1 minus 1 over 2. It's just going to be 1 over 2 minus 1 over 5x to the power of 2. Okay. So basically now we've basically done that first step where I say that you need to basically simplify your expression. We have simplified this expression. It doesn't get any more simpler than this, right? Okay, so here, guys, we can now start differentiating using the rules of differentiation, right? So what does the rules of differentiation say? It's going to be that the negative 5 multiplied by 1 over 2, right? Negative 5 multiplied by 1 over 2, right? And then it's going to be x, right, to the power of 1 over 2 minus 1, right? Okay, that is basically the rule that you need to apply. Minus, okay, it's going to be 1 over 5 multiplied by this 2, okay, times it by your x to the power of 2 minus 1. Right, so here, guys, I'm basically showing you how we basically apply your rules of differentiation. Okay, so if you say negative 5 multiplied by 1 over 2, you're going to get negative 5 over 2, and then x, right, to the power of 1 over 2 minus 1. 1 over 2 minus 1 is to the power of negative 1 over 2 minus, right? 1 over 5 multiplied by 2 is 2 over 5, right? And then times it by x, and then 2 minus 1 is 1. So you can just leave it like that, right? Okay, you can put 1 there if that makes you feel comfortable, right? And then, guys, we have basically now differentiated this using our rules of differentiation, and that is basically going to be our final answer. Okay, so here you basically get a mark for, let's go there. Okay, so here you're going to get a mark for showing that you see that here, if you basically simplify the negative 5x multiplied by x to the power of negative 1 over 2, you're going to get negative 5x to the power of 1 over 2. That's where you're going to get your mark there, right? And you're going to get your mark here once you've basically differentiated, and you get your negative 5 over 2 times x to the power of negative 1 over 2, and you're going to get another mark here where you've basically differentiated that as well to get negative 2 over 5 multiplied by x, right? And it's basically out of 3 marks. Okay, so that's basically where you're going to get your marks, right? So I basically did your extra steps here so that you guys basically see how we got to our final answer, because that's what distance learning with Lee is all about, right? We need to basically ensure that you understand all the steps that you're supposed to follow to get to your final answer, right? Next question, 7.2.2, guys. Like I said, the first step that we need to do is we need to ensure that we basically simplify the expression. That's the first step. We need to simplify the expression that is given to us, right? So we basically need to simplify this expression. So how can we simplify that? So it's going to be d over dx, right? Let's simplify. X multiplied by x is going to be x squared. X multiplied by minus 2 over x is going to be equal to minus 2. Okay, x multiplied by minus 2 over x, right? What do we see? It's going to be equal to minus 2, right? And then positive 2 over x multiplied by x. So positive 2 over x multiplied by x is also still equal to positive 2. And then positive 2 over x multiplied by negative 2 over x, right? So 2 over x, okay? 2 over x multiplied by negative 2 over x, right? It's going to be equal to negative 4 over x squared. Okay, I'm going to simplify this further. So it's d over dx, right? It's going to be x squared. Okay, positive 2 minus 2, zilch. Okay, minus 4 over x squared. Right, but we can still simplify that further, guys. We can still simplify that further, right? Okay, how do you simplify that further? Okay, so it's going to be d over dx. Okay, x squared, that's already in its simplest form, guys, that x squared minus then it's going to be 4. If we move this x squared from the denominator position to the numerator, what happens to the exponent? 2. It becomes x to the power of -2. And then from here, we see that we have basically simplified, right, this expression. Once we've simplified the expression, then we need to apply what? Our rules of differentiation, right? Okay, I'm just going to rewrite that d over dx here so that you guys see what is happening. Okay, we said that it is equal to x squared plus 4 x to the power -2, right? Let's apply the rules of differentiation, right? It says that it's going to be this 2 multiplied by this 1 that is here, right? So it's going to be 2, it's going to be the 1 multiplied by 2, right? X to the power of 2 minus 1. Okay, that's the rule. Plus, okay, this 4 multiplied by this -2, okay, to the x, right, to the power of -2 minus 1. Okay, that is our rules of differentiation, right? I still need to do a whole video tutorial where I do like a summary of the rules that you guys need to know when it comes to calculus. Yeah, I still need to do it so I can refer you guys to that video. Okay, but I'm sure at this point, guys, you guys should be able to remember these rules, right? But that's fine. Okay, so 1 multiplied by 2 is equal to 2. X to the power of 2 minus 1 is 1. You can just leave it as 2x plus, okay, but you guys are going to see that it's going to change into a minus. Let's say plus 4 multiplied by -2 is -8, right? X to the power of -2 minus 1 is -3. Okay, let's basically simplify that further. It's going to be 2x, right, to the power of 1. It's just 2x plus, or it's just going to be -8 x to the power of -3. Okay. Okay, and we have basically differentiated that equation using the rules of differentiation, right? So what's important, guys? First thing you need to do, you need to first try and see if you can't simplify it further, right? After you've simplified that further, then you just apply the rules of differentiation to basically solve your equation, right? So where do you get your marks here? Okay, so for question 7.2.2, you basically get a mark for basically showing that x squared minus 4x minus 4 all over x squared. So you get like a mark there, okay? And then you get another mark for showing, yeah, that you can basically change this 4 minus 4 over x squared to minus 4x to the power of -2. You're going to get another mark there, right? You get another a mark for that 2x, right? Differentiating using the rules of differentiation, and you get another mark for also differentiating there using the rules of differentiation, right? And that is it, guys, for today's video tutorial. I hope that it was super informative. I hope that it helped you guys a lot, right? Okay, and in the next video tutorial, guys, we are going to be going through question 8, and we're going to be basically answering questions that relates to a cubic function, right? Our point of inflection, right? Our stationary points, right? Still under calculus. So please make sure that you have clicked on that notification bell so that you do not miss the video tutorial when it drops, all right? And that is it, guys, and I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.